Good morning, everyone. Welcome to this lecture of cloud computing. So, in this lecture, we'll discuss about the second part of our service-oriented architecture that we call as your message-oriented architecture. Sorry, message-oriented middleware. So, in the message-oriented middleware, we are using one type of bus, right? You know that in computer, bus is used to transfer the data from one component to another component, right? So in computer, we have seen when you communicate the data from one component to another component, you require bus devices, right? So if you have studied computer organization or microprocessor, you may have studied there are three different types of bus, like data bus, right, which is bidirectional in nature. Okay, and the second type of bus is called as address bus, right, which is unidirectional in nature. And third type of bus is called as a control bus, right. So these three bus you know in computer organization architecture. So in service oriented architecture also, in order to enable this message oriented middleware, we require bus, right? So that bus is called as ESB. So here you can see in the diagram, we have enterprise service bus, right? So sometimes what happens, this enterprise service bus is an intermediary between the client and server, right? One side client is there, and the other side server is there, right? Or so here ESB is present, right? In this architecture, if you see ESB is present here. Similarly, if you see one side user is there, another side the cloud service provider is there. In between user and cloud service provider, you have enterprise service bus, right? So it is providing a middleware, right? ESB is providing a middleware, or you can say it is a runtime environment. So I told you about one of the project also. If you have installed into your computer system, the project name is BUINC, right? Berkeley Open Infrastructure for Network Computing. So if you have installed this project, it is also this is a platform in which you can run various grid computing projects or various real life projects, you can say, right? So this platform is designed by University of Berkeley, and this platform uh, enables to run you can say many scientific and engineering applications where the resources, if you see, the resources are voluntary. Like I can participate with this BOINC project if I want to share my resources with this particular platform. So for a sake of illustration, just I am telling you, you can search in your computer system. You go to Google, right? You search about BOINC. So you can see here the website is boinc.berkeley.edu, right? Go to this BOINC platform. So it is a purely volunteer platform. So in this BOINC platform, you can download. So let me show you that here, right? So software platform, you can download in two things. One is you have to download either the BOINC, or if you want to download BOINC with VirtualBox. So once you download this BOINC and install it in your computer system, you can get things like this. Which I am showing you. Okay, this is your BOINC manager, right? You can see. Suppose let me go to the normal version. First, you see the basic version, then you come to the advanced panel. Simple. This is the platform, that is BOINC manager, right? So here you can see in the project part, I have added one project name that is called as climateprediction.net. So this climateprediction.net enable us to know what is the temperature, or whether there is any rain or not, or whether there is any flood or not, or whether there is any cyclone or not. So this project is responsible for that, right? So if you want to add a project any project, any number of projects you can add to this BOINC platform. So if you want to add a project, I have added only one project, that is our climate prediction.net. If you want to add some other projects, you click add project. You can see there are a lot of projects are there. These are the project names. Okay, one of the popular project also I told you in some class, if you remember, that is called as ACTI at home, right? This ACTI at home is also a scientific engineering application project, which the full is called a source for extraterrestrial intelligence. This project is also running under this BOINC platform. Okay, and these projects are divided into multiple category. Like some projects are there with respect to biology and medicine. Some projects are there with the cognitive science and artificial intelligence, distributed sensing, earth science, mathematics, computing and games, multiple applications is added later, and physical science. So if you want to see what are the projects available with cognitive science and artificial intelligence, you can see there are two projects available. One is mind modeling at home, another is MLC at home. The details of the project you can get here, right? If you want to visit a project and who is which organization is hosting this particular project, you can get the details here. Okay, so your computer system can add this project into your into BOINC platform, whatever you have installed in your computer system. So you simply click the next button, right? So now it is communicating with the project. Okay, then you have to open a particular account. So let me create an account here. Okay, I have created one account to share my resources with this AI project. So if you click next, then the project is going to be added successfully. The project has been successfully added, and when you click finish, your web browser will go to that page and where you can set your account and preference. Okay, that is different thing. Okay, so you can see here now mind modeling project is added to you. Okay, so this is a very big project, right? Running mind modeling project require very huge number of computational resources. This huge number of computers is required. Out of that huge number, you are contributing as a single user, right? So what happened? This big project is now divided into small chunks. A small chunk of work is going to be assigned to your computer system, and your computer system is going to run that thing. The computer system is going to run that small project, and periodically they will collect the data from you, right? So similarly, this big project is assigned to multiple voluntary user, and they are executing their work whenever your computer system is free. Okay, and once the work is done, the work will be the result is again back to this particular project so that they can accumulate that again. Right? So all of you please install this BOINC platform and explore it. This is the advanced view you can see with more details about the project if you want to see. Like sometimes you will get notices, okay, like whether the project is running or project is having some issues, right? So you can see here some work is assigned to me and it will be executed once my computer system is free, right? So you can also see you can remove these projects obviously, okay, and whatever work you are doing with respect to this particular project, periodically the updated result will communicate to that particular project server, right? And different tasks and transfer statistics and these analysis you can get from BOINC, right? So it is providing a platform to do the particular work, right? Similarly, if you see in the service-oriented architecture, we have enterprise service bus. This enterprise service bus is going to provide a runtime environment, right? So one side you have user, another side you have provider. Both user and provider is connected to the enterprise service bus in order to get the service, or in order to provide the service. So in this picture you can see first one is called as portals. So we know what is portal, that by the help of that portals we are able to access a cloud service provider. Okay, either through a web browser or through a specific portal, we are going to access the cloud services from a cloud service provider. It may be a service request that is in the form of SOAP protocol, right? That is simple object access protocol, that is J2EE or .NET, right? That may be also your you can ask the services through this one, or it may be a business to business transactions what we are doing by a business company, right? To another business company, or it may be a B2C, business to consumer interactions what we are doing with Flipkart and Amazon, right? So all the request is coming to the enterprise service bus. So sometimes we can call this one enterprise service bus as a broker. Okay, this is called as a broker. So I told you two things, or we can say this one is called as a brokering. It is doing the brokering job, and in this particular side, user may be there, or a user may be there, or instead of user there may be a broker. So don't be confused with this term, right? Instead of user, a broker is requesting a particular service. For enterprise service bus is going to provide you the brokering mechanism. Brokering mechanism means you are doing a matchmaking process. You know both party 1 and party 2. You have the requirement of party 1 and you know what kind of requirement can be satisfied by the second party. So what you can do, you will do a matchmaking process. That is called as a brokering thing. Okay. So if you see in a user perspective or a broker perspective, what they may need some service flow. They may need the data and their analysis. There may be some existing applications, but which is hosted in a particular server they want to access, or it may be a new service logic. Okay. So it is the nothing but the applications which is requested by a particular user. Similarly, you can see here a more detailed view, right? You can see again in the user end, we have a business applications like B2B and what we discussed, B2B, B2C, right? Or there may be a data sources. It may be in any format. Whenever you go for the middleware, the data sources, whatever coming, it may be in any format. Somebody may use HTML format, somebody may use XML format. So many formats are there. It may be related to a partner applications, like Walmart is giving product to the, let's say, DMart or to the Reliance. Then they are going to provide that product to the consumer. The first type of transaction is, you can say, business to business transaction. The next transaction which is carried out by DMart to us, that is called as B2C transactions. So it may be partner applications, multiple business to business organization. They want to do business through the service oriented architecture. Okay, they can also request to the ESB. So it may be simple, that is browser or rich client. Like I told you in some class about the fat client and thin client. Like that we discussed about the fat server and thin server. It may be a connectivity services or it may be a mobile devices. So there are a lot of applications are there. So these applications are requested to the ESB. Okay. On the other end, if you see the provider end, you may have REST, REST, or you may have SOAP protocol, right? You may have HTTP client and server. It may be a J2EE server, or it may be VPN, or it may be a file, or it may be a file transfer protocol, right? So these things are processed by the help of our enterprise service bus. You can see there are a lot of things are provided by ESB. I repeatedly told you that whenever we are talking about middleware is also responsible for security. Security mechanism is provided by your enterprise service bus. Similarly, messaging, or you can say protocol binding, or you can say interceptors, data transmission, service locator, all these things are provided by your enterprise service bus. So that is called as your message oriented middleware. What we are doing, you are propagating the message from one end to another end through a middleware, right? That's why it is called as message oriented middleware. So the services are interacting with each other. How the services are interacting? The services, it may happen that one service is interacting with another service. Okay, one service S1 is interacting with another service S1 dash. It may happen that one user is requesting a particular service, right? So whatever may be the case, the main thing is that the interaction between two different party through a message, right? So what may be the issue will come, what is the issue with respect to this conversation? The first issue is that like whenever we are visiting a new place, we are habituated with the general language like Hindi and English, right? We do not know their local language. Okay. So whenever you are interacting with another person, you have to ensure that that person knows Hindi and English, right? So what happened in this case? The conversation issue will happen, right? Similarly, in this case also, if you see, whatever message that they are communicating or whatever things we are talking with another person in a different place, in outside or in a place where we do not know the local language, so they may be available in the different formats. Okay, somebody may tell in some language, you may be interested to know in another language. So what you need a translator, where translator can transfer the things from one language to another language. So these different formats, what do we call that formats? This is taken care by your APIs. Okay, a variety of different formats, that is nothing but your APIs. So this conversation also depends upon what protocol both side party using. One may be used HTTP protocol, another may use FTP protocol, right? So these protocols may be used. And what is the transport mechanism between two different parties that you have to decide? That is taken care by your enterprise service bus. For example, if you take an example here, somebody may interested in firewall, somebody want to process something in UDP, somebody want a special features like fault tolerance. So if you see that such type of things, the subscriber or the author of the service, they should not worry. Like here it is mentioned, the author of the service should not worry, should not need to worry that a special port is to be used to avoid firewall. Okay, or we need to use UDP, or we need to a special feature like fault tolerance. So the author of the service should not worry about that particular thing. That thing you have to provide through a middleware or through an enterprise service bus, which is there in the middleware. Okay, so that what will happen? If everything will be provided in the form of middleware, okay, so you can achieve a good latency, the delay will be reduced, because if everything will be monitored by the author of the service, the delay will be increased. Okay, so especially when you focus on the long distance communications, you have to focus in this, right? ESB also refers to the case the bus supports the convenient interaction of many components, often into different styles. So the components are now integrated. If all the components are integrated to the middleware, then middleware can process the things without any delay. So irrespective of the distance of the communication, so the data can be communicated, the message can be communicated from one unit to another unit. Let us see another example. So there is two things you can see here. There are two message bus implementation you can see here. First one is focusing on the services. Means one side you have service, another side you have another service. You can say one side client service, another is server side also service. So you can see here the client side. If you see the services are called a service 1 to up to n, and another side we call it a 1 days, 2 days up to n days. Right? How they are communicating? How the services can communicate with each other through a message bus, like our ESB. What this ESB is responsible? ESB is responsible for the formatting. What type of message you are communicating between the service, that is also responsible. They are also responsible for communication and routing abstraction. You know, routing means you are transferring one is the sender and receiver. Both are not in the directly connected to each other. So you are following a particular path to reach to the destination. So this complete illustration, okay, if you see the complete component, so this can be hidden by the help of the middleware. So middleware is going to provide you that particular service. If you see in the other hand, what we did, this component is now replaced with a set of broker. So you have m number of brokers, right? You have m number of brokers. Each and every broker is responsible for some work. Okay, so they are communicating between two different clients. Okay, and each and every broker has a particular queue. Okay, so that whenever a request is coming, they can be placed in the queue, and the broker is going to solve the things whatever available in this particular queue. Okay, so you can see this the middleware, this part we are now replaced with a set of broker. Okay, so we are in ESB. If you see, if a source want to communicate with destination, whenever a source want to communicate with a destination, so they may not open a specific channel, or you can say dedicated channel, in order to communicate the message from a source to destination, right? Like suppose this computer again want to communicate with another computer system, right? They should not create a specific channel in order to communicate between two different components. Just you have seen that same thing in the mesh topology. So what is the solution? The solution is that you have a middleware, right? The middleware is connected to all the clients or in all the servers or in between the services or in between the clients. They have a middleware. So you have to inject your message into this bus, and this injection of the message should have enough information such that the services can be reached to a particular destination, or the message whatever you want to communicate, that you can communicate, that you can send through this bus. So while injecting the message, you have to ensure that sufficient information is there. Like whenever you are sending a packet in network you have studied, in that packet you have a header bit and a trailer bit, right? In that header, you are mentioning the destination address and a proper route. So this information enables the network to make your packet consistent, and it should be delivered to a proper destination. The same thing we are doing here, but we are doing through the ESB, that is Enterprise Service Bus. We are propagating the message. So you have to ensure if you have a sufficient information, then only you can say that it will be delivered correctly. If you do not have enough information, then it may be reached to a different destination, if that is not clear. So you can see in the previous diagram, so you have a oval. In a oval, you have a black dot, right? So this indicates the injection of the message. Okay, what we are doing injection here? We are loading the code into e-service. Okay, so if you see an example, our smartphone is an example. Smartphones or desktop, you can say, or laptop, whatever handheld devices we are using, they can be called as a client. So I am sending a message to you. You are another client, right? So one client is connected to another client through a brokering system or through a middleware. And this network is completely distributed. This is not a centralized network, right? So you can see the message bus is implemented with a set of broker in the second figure. First figure, message bus is there. Now we have replaced this message bus or the middleware between different services with a set of brokers. So the use of multiple brokers allow the bus to scale to many clients and large message traffic. The reason for using multiple broker, one person can ask, why not there is a single broker? So the reason of multiple broker is that each broker is responsible for some traffic. Like internet, we have lot of servers, right? So all the traffics, if it will reach to a single broker, then what will happen? The service will be unavailable, or the machine will be overloaded, then it will fail to provide services to all the customers. That's why it is saying, in order to manage the large traffic, we have multiple broker. So one broker is responsible for many clients or a group of clients. Okay. Whenever these clients want to communicate between each other, or one client want to communicate with another component, what they will do? The broker are just the special servers or services that receive the message and perform the needed transformation and routing on them and send out the new messages. So broker will queue your request. In order to implement this broker, if you are thinking how this broker can be implemented, this broker is simply placing your request in the queue and it is managing your queue. And each and every message has enough information which tells the brokers to deliver it to a correct destination. So sometimes what happens, whenever I want to send a particular message, so it is point to point. Point to point means one client is communicating with another client. So that is called as a point to point messaging. Sometimes what happens, like radio kind of thing. Radio kind of need to broadcast a particular thing. So there is a single source with multiple destinations. That is called as a broadcast or selective multicast. Okay. So not necessarily one component want to communicate with another component. It may happen that a same message you want to communicate to multiple clients. Okay. There ESB plays an important role. If you want to see the live example, IBM uses one message queue series that is now called as WebSphere MQ, which is providing this brokering mechanism. Another one you can see the main use before going to the Narada brokering. It is a very Narada brokering is a very famous one. Before introducing that, let us see what is the use of this message queue. The message queue, if you remember our Hadoop implementations, or I told you about the word count problem. In word count problem, I told you there is a master. Okay, there is a master and there is a several worker. There is a master and there is a several worker. What is the job of the master? Master need to divide a work into multiple parts. Okay, after that what happen? Master is going to assign individual work to a particular worker. For example, this I am assigning to worker 1, this I am assigning to worker 2 and worker 3. Okay, and this request you can place in a particular queue. Okay, which can be assessed by the multiple worker or you can assign to the multiple worker. So when the worker will execute a particular work, okay, or when they complete a particular work, they will again return the result or the outcome to the master. And master is going to again combine the things. So such type of systems is depend upon your message queue. Okay, the message queue plays an important role. Like we have seen in the word count problem, we are maintaining the key value pair. Okay, key value pair means key is a word. For example, some word, let's say XYZ, and its value it is repeated 3 times. That we are accumulating. We are generating the key value pair accordingly. We are generating, right? So that is another concept in the message-oriented middleware that is very well known, called as your pub/sub model. Pub stands for your publish, sub stands for your subscribe model. So this pub/sub model is generally used for notifications. So you see WS notification we already discussed, that is web service notification. I told you while we are discussing WS icon star, so there is one type of web services that is with respect to the notification. Okay, notification. So that is possible by the help of this pop-up model. What is the purpose of this pop-up model? Same as whatever we are doing in YouTube. Like you want to listen the music of a particular singer, then you are searching their song and you are subscribing such song. Okay, or you are visiting a particular event. Here it is called as event, and in that event, what you are doing a subscription. Okay, so whenever you made a service, whenever you made a subscription, what will happen? Whenever the provider is publishing an event, you will get a notification. Okay, so this pops up describes a particular model for linking the source and destination for a message bus, where you can see publisher, producer of the message and label the message. Whenever you are uploading a particular video in YouTube, what you are doing, you are labeling that video with a message. Okay, you have a channel or you have an event. In that event, you are publishing various messages. So what the subscriber will do? Subscriber receives the message. How it is receiving the message? It is receiving the message which it wants to, which it subscribes, or which the user wishes to receive the message, associated message. Suppose I am interested in XYZ event, then I will subscribe XYZ event. So whenever there is a new thing, then it will be notified to me. So if you see here, what the publisher is doing here, the publisher using a content-based message selection. The publisher know what are the things you are interested for, or what are the things you are not interested, or what are the things you have explicitly mentioned that you are not at all interested. So such type of filtering things will be done by the publisher based upon the content. Like some videos are there, right? Suppose let's say C programming videos are there. C programming videos are generally watched within a age group of let's say 15 to 25. So based upon that search criteria, the provider can provide or publish the message, and if a subscriber in the range of 15 to 25 age, they want to see the new post regarding the C programming or about a particular channel or particular event, they can subscribe. So that is called as our content-based message selection. And obviously, if you see the publisher and subscriber, a lot of publishers are there and a lot of subscribers are there, right? So the relationship between this publisher and subscriber is called as your many-to-many relationship. The relationship between, if you find, generalize it, it is M2M relation. Okay, so this publish subscribe messaging middleware allows straightforward implementation of your notification and event-based programming model. So it is providing the notification based upon your past history or a user's past behavior. Based upon that, it is going to providing the notification. Okay, so it is implementing the event-based programming models. Similarly, if you see the queuing messaging system, that is your message queue, what we have seen, that is we discussed about the WebSphere message queue, okay, which is provided by IBM. So for this, you can use your Java Message Service (JMS), which specifies a set of interfaces outlining the communication semantics, the meaning, right, in publish and subscribe and queuing system. So JMS uses your publish subscribe systems and your message queue. Similarly, a lot of examples are there. Like one of the example is called as your null MQ. Okay, so that is a message framework which was deployed, which was used to deploy around 2,500 products as on 2010. Okay, so out of there are so many things are there, so many message queues are there. I'll compare. I'll show you the comparison. If you are interested, you can go for the such message queues. So one of the example is your rule MQ, which holds 2,500 payment by 2010. Okay, so it is integrate the things with your existing systems. So new products is coming, it is integrating with new systems with your existing systems. Also supported various protocols like POP, IMAP, FTP, RMI, SOAP, SSL, and SLP. These are the protocols are supported by this messaging framework. And I told you there are two web services are there. One is WS eventing and WS notification is responsible for the entire thing. So these are the web services. Similarly, ActiveMQ is provided by your Apache. It is an open source message broker. WebSphere MQ, you know, that is provided by IBM. And one of the open source and very popular and well-known one is called as Narad Brokering. Narad Brokering. So it is an open source one. The open source, you can download it, right? Narad Brokering, if you visit their website, you can download that tool, which is acting like your middleware, right? So it supports the software multi-point controlling unit for multi-point video conferencing. Like, I'll tell you an example in the next slide. Suppose US people and Europe people, they want to collaboratively do a video conferencing. So that is possible by the help of Narada Brokering. So earlier such systems are not there. Now due to this COVID-19, we have lot of systems like Zoom and Google Meet and WebEx and Microsoft Teams for video conferencing, but earlier these things are not there. Okay, so there this brokering, Narada Brokering is providing in the video conferencing mechanism. Similarly, there is another message queue is there that is called as Rabbit MQ, which uses your advanced message queuing protocol. So with respect to the message queue, the protocols are different. The types of services they are providing is different. The types of security policies is used is different. Like you know that while in the beginning phase of our pandemic, people claim that the Zoom is having some security issues, right? This type of security mechanisms, if you see with respect to these message queues, they are different. So this is a complete comparison. Amazon is providing you the simple queue service, Azure queue, ActiveMQ, and MuleMQ, WebSphere MQ, and Narad Brokering. Where Narad Brokering is completely open source. So you can compare these message queues in order to say that which message queue is well suited for a particular client. So whenever you are getting, whenever to go for a particular brokering mechanism or a message queue mechanism, you have to see what are the system features they are providing. Like you can see there are system features are reported in the column 1 with respect to what is the length of the message also. Because some providers are restricting the length of the message. Okay, like you can see in Amazon Simple Queue service and Azure Queue, it is restricted to 8 KB. One message is restricted to 8 KB, but such restrictions are there in other message queue. Similarly, other system features you can see with respect to security also. You can see who is using SSL, who is using SHA 256. Okay, secure hash protocol. Okay, hash protocols, right? Hashing mechanisms that you can see, and some other things also you can get. You can compare one message queue with another message queue. So you can see some of the real life examples, like we have seen some real life example in the cloud computing perspective. Here also you can see some live examples, like environment protection case, we are using Narad Brokering, or internet conferencing, also we are using Narad Brokering, or earthquake science applications, also we are using Narad Brokering. So these are the 3 live examples where the Narad Brokering is used. Real life examples, right? In environment protections, you may interested to know how much carbon dioxide is generated, how much renewable energy is used, how much non-renewable energies are used, how we can reduce it. Such type of things you can be reported to this environment protection. There is another project by Clemson University that is called as BOAT project. So it is a part of the program of integrated study of coastal environment sustainability, which is popularly called as PSS. Okay. So which addresses the environment sustainability issues. Like land brokering is providing you environmental protection. Here also, this project is responsible to know that whether groundwater is available or not, or whether surface water is available in a particular location or not, or quantity monitoring, weather and a variety of ecological measurements. Such type of things can be provided by this board project. Board project also uses your PubSub messaging system, like Nano Brookering is also using a PubSub messaging systems. It is providing a flexible and reliable layer to move observation data from a wide variety of sensor sources to user that have diverse management processing requirements. So they are collecting the data through various sensors, right? So once they are collecting the data, like BYNC also, they are collecting the data and they are computing this data in various machines so that they can get some meaningful information or they can do some prediction, right? For that, we are using these middleware applications. Similarly, there is a commercial internet meeting software like Anabus. So in this Anabus, what happens? Online meetings you can do with various country people. Like one of the typical example is given here, where United States and Hong Kong and China peoples they are using this Anabus platform to do online meeting. Or if you want to do a video conferencing or audio conferencing, so that is possible through this Anabus. Anabus also provide a whiteboard. Nowadays it is very clear, like Google is providing various features, right? So that multiple people can use a single board to write a particular thing. Like I can share my screen and I can write something. Another person can write this other things in that board. So such type of sharing mechanisms is available. And also content disseminations and messaging requirement. Now these attachments are also available if you want to share a particular file with the people who are attending a particular conference also can be possible by the help of this particular software, right? Similarly, another project by NASA that is called as QuakeSim project, which is dealing with your earthquake science. So basically here they are dealing with that, they are collecting the observation data through the GPS, global positioning system. So there are a lot of GPS are there or sensors are there, GPS sensors are there. So they are collecting the data, observation data, so that some meaningful conclusions they can make with respect to the earthquake analysis. So they are also using this data brokering system, which is going to provide it, right? And they also say the webcams can be treated as a sensors in order to collect various data from various sources. Okay, the last part of today's discussion is that you can see this is a typical example where you can see the GPS sensor of a particular site. There are a lot of sites are there. Like Google, you are pinning to a particular point. Suppose you want to read a particular location. So what you are doing, you are pinning to a particular locations and you are taking photos of that particular location and that particular location information you are sharing, right? Similarly, you can see here there are a lot of GPS sensors are there, but it is showing a particular GPS sensors by the which points to a particular locations. And that is southern part of California, which uses a narrow brokering system. So this map displays the time series produced by one of the GPS station. So some analysis they are doing with respect to a particular station, to how the performance is increasing or how the performance is varies, or what may be the possibility of earthquake today, or what may be the possibility of earthquake in the upcoming future. So this thing can be possible by the help of NADA brokering system.